Okay, Math 9, let's get after it. Here is a short video on multiply and divide fractions. So remember, you have your full lesson you can watch, and this is just a short one if you need a couple more examples. Okay, so the goal is not to just multiply the tops with tops, bottoms with bottoms. We can do that, but that's procedural. You're going to get really large numbers. Right here, you'll get, I think, like 104 over something really big. And then you'll have to simplify down because we want things to be simplified. So rather than just multiply them, let's simplify before we multiply. And we'll do that by canceling out common factors. Now, some of you might feel confident and go, okay, well, I know that I can cancel this with this and just do things like that. Like you've seen this before, you've done this before. And that's fine. If you've done this before, you're not watching this video. You already know what you're doing. So for those of you that want to see this in a little bit longer haul, look at your numbers here. This is a prime number. Can't break this down. Okay, it's stuck. So I have 13. Now 24, I know it's 3 times 8, right? I know that 24 is 3 times 8, and I'd be happy there because I have an 8 on the top. But if you don't know that 24 is 3 times 8, you might know that, well, it's 2 times 12. And that's great. But 12 we can keep dividing, so let's keep dividing. 12 is 2 times 6. Well, it's 6 we can keep dividing, so let's keep dividing. And 6 is 2 times 3. So now you have only prime factors, and 2 times 2 times 2 times 3 is 24. Now, at the same time, you'll be like, okay, well, 8 is 2 times 4. I know that. I feel confident there. Good, good, good. But what about 4? 4 is 2 times 2. And now this weird outlier, 91. Now, here's just something helpful. If you see a 13 on the top, you might think, okay, maybe I can divide 91 by 13. But remember also that if a number is not prime, then it is divisible by primes. And we only have to try the prime factors below its square root. And the square root of 91 is less than 10 because the square root of 100 is 10. So that means if 91 is going to be divisible, it's going to be divisible by the prime numbers 2, 3, 5, and 7. Again, divisibility video, primes video, if you want a little bit more clarity there. Now, 91 is not even. I can't divide it by 2. 9 plus 1 is 10. Those digits don't add up to a number divisible by 3, so I can't divide by 3. 91 is not ending in a 0 or a 5, so I can't divide by 5. So the only prime that I'd be able to divide 91 by, if I could divide it, would be 7. So let's just try that. 91 divided by 7. 7 goes into 9 once with 2 remainder. 7 goes into 21 3 times. So that means 91 is 7 times 13. Now from there I have everything broken down, so now I can cancel out common factors top and bottom. I have a 13 on the top divided by 13. Remember, you end up with little ones. We don't have to write those ones, they're redundant, but I'm going to keep them here just so you can see what happens. Because now 2's, and they'll become little ones, right? 2, because 2 divided by 2 is 1. 2's. The reason why the ones matter here is because everything on the top cancels out, right? The stuff's all gone. So you'd be tempted to say we have 0 left up top, but we don't. We have a whole bunch of ones, and 1 times 1 times 1 times 1 times 1 is just 1. And then on the bottom we have a 3 and a 7. So our solution there, fully simplified, is 1 over 21. A lot easier than doing the big multiplication and trying to simplify from there. So simplify before you multiply, okay? Now here we have division. So there's only one fine detail for division is first I'm going to convert this to an improper fraction. And that's going to give me 2 times 7, 14 plus 1. So I have 15 over 7 divided by 5 over 14. Now the piece to division is, some kids will say KFC. I actually prefer KCF. Keep the first fraction. Change the symbol to multiplication. Flip the second fraction. Now, I have a really good video and explanation in my division of fractions in section 1.4, and I explain why that happens in rather extreme detail. And then I also show another way of dividing fractions, but this is the best way to do it, convert to multiplication. Now we're going to cancel out some common factors, and I realize a little typo there. That should be 14 over 5, because now we're just back to a multiplication. 15 is 3 times 5, 7 is prime, 14 is 2 times 7, 5 is prime, and I'm just looking for common factors. Well, I have a 5 on the top and a 5 on the bottom, 7 on the top and a 7 on the bottom. And now in this case, I have nothing left on the bottom, so it's just a 1 down there, right? And I have 3 times 2, so the answer is 6. So you cannot cancel factors out until you've converted to multiplication and flipped your fraction. So let's look at a couple more. So here we go again. I'm going to fast track this a little bit. Those are both prime. 28 is 4 times 7. So this is where it gets helpful to know your multiplication basics, because if you know that 28 is 4 times 7, then you already identify the fact that you have a 7 on top and a 7 on the bottom. 21 is 3 times 7. So you actually have a couple options here with the 7. You can cancel either of the 7s. For the sake of this one, I'm going to cancel this one with this one, and I'm going to cancel my 3 with my 3. What am I left with here? 4 over 7. So much easier than multiplying these numbers together. If you were to multiply these numbers together, you would get, 84 over 21 times 7, 147. And then you'd have to simplify from there. That's a lot harder to do than to simplify first. Break the small numbers down into factors. So now, second example, we'll multiply and add. So we get 13 over 7. Then at the same time, I'm going to change the sign and flip to 11 over 26. And now I will simplify. 13's prime, 7's prime, 11 is prime, but 26 is 2 times 13. So now you see you have factors that will cancel. And what are you left with on the top? 11. On the bottom, you're left with 7 times 2, 11 over 14. So I kind of made big emphasis about this in our earlier videos, but understanding your factors, being able to divide, knowing your multiplication basics, this just keeps coming around and around and around, and it makes life so much easier. So please practice that. Flashcards, work on your multiplication basics on your own. You're never too old to learn. It'll just make this stuff a lot easier, a lot more fluid. So let's look at one more here. It's a rather big one. The trick here is to work from left to right. Okay, don't worry about your order of operations. We'll talk about that in our BEDMAS video, but you're going to want to work from left to right anyways. So 2 over 3. First thing we're going to do is we are going to change our division to multiplication. We're going to flip. And then you can see you have multiplication. And now we're going to convert this to 5 over 2. But then we're also going to change to multiplication and flip that to 2 over 5. Because now I'm only dealing with multiplication statements. You can do that step first. Now the next step, I'm going to identify my factors. So I have 2 over 3, 9 is 3 times 3, 4 is 2 times 2, 5's prime, 6 is 2 times 3, and then I have 2 and 5. So now I have everything broken down into primes. I've done all my flipping, so I only have multiplication statements. So now I'm just looking for common factors. 2 on the top, 2 on the bottom, 3 on the top, 3 on the bottom, 3 on the top, 3 on the bottom, 5 on the top, 5 on the bottom, 2 on the top, 2 on the bottom. What am I left with? Just a 2 on the bottom. So what does that give me on the top? A 1, and on the bottom, a 2. So I've simplified all the way down to 1/2. So simplify your numbers into primes all the way if you have to. You can never go wrong simplifying down into primes. You're looking to cancel out common factors. And don't forget, when you're dividing, you need to change the division and flip the second fraction before you can do any canceling. So practice, practice, practice. You're going to get good at this. This concept in general carries over all the way through up to grade 11, 12 for sure. The fractions just get a little bit more complicated. And by that, I mean they start to contain letters and funky things. So be ready for that. The concept holds true. Thank you so much, and I will see you next time.